My name's Greg, and I'll be your guide around the bridges of Kreuzberg today. What we are aiming to do is cross the bridges only once. It is a beautiful day today, but before we go for a walk, we better be having a look at seeing if this journey is even possible. As you can see, we have 7 bridges to cross and 4 areas of land to touch. Sounds pretty easy, but I can assure you that it is not. This has been a mathematical problem that has been used for students all over the world for many years now. We're just lucky to be visiting today. How about we start from the most recognisable person for a solution? This man is Leonard Euler. He produced the first paper to have a mathematical solution to this problem. In August 1724, he released a paper explaining the journey was not possible, and to show this, he said you must add one more bridge to the total number of bridges, then use his formula to find out how many times each landmass must be crossed, then total number of the formula answers, and the totals must be the same. In this case, it shows our walk is not possible. There could be an easy way to look at this problem. It's called graph theory. So let's have a look now. These are common pictures kids in the dark ages of no iPads used for fun. They had to be able to trace over every line without going over the same line twice. In fact, this is what we're doing with our walk. This is an Euler path, and graph theory can explain why this is the case. In graph theory, points are called vertices. They have sides being edges, and where the edges meet the vertices, that's called degrees. Degrees can be odd or even depending on how many edges they have. As you can see by these shapes, the only ones that can be traced are the first and the third one. That is, they have 0 or 2 odd degrees. So I hear you thinking, but how does this help me know if I can complete the walk today? By having a look at these pictures, you can see that no line has been traced over twice, except for the second example. You're able to go around each of the edges, tracing the edge perfectly through the vertice and back to the beginning if need be. Here we have a picture of our bridges again, but let's put some letters and numbers on there to make it a little bit easier for us to have a look at later on when we open up our Euler paths. For each landmass, each bridge has a letter or a number. That makes it a little bit easier. Here we have the bridges and lands as vertices, edges and degrees, which matches from the picture just before. This shows that there are 4 lots of odd degrees being at every vertice, so we can't do the walk in this way. But that has me thinking, where could we build a bridge to be able to do our walk? We'll need an extra bridge to make sure that they have no more than 2 or 0 odd number vertices. So between B and C, D, in yellow, we have an extra bridge. This means that A and B have odd numbered vertices, and B and C have even degrees. This means that we're able to do our walk today, because we'll be able to have everything lined up as per the Euler solution, as well as graph theory. So what are we waiting for? It's a beautiful day outside. Let's get going.